we're going to make a continuations of differentiation. I'm going to use just the example which is here to remind you what we did last time, and then we continue from there to do 2 to 3 questions before we wind up. So the question is, differentiate the following function. So the question is, differentiate the following function. So what we have here is just a function. This question can be find the gradient function. Also, it can be find the derived function. The same questions can be asked, find the derivative. Find the derivative. So, the term derivative, the gradient functions, and the derived function is the same as differentiate the following function. So, I'm going to take you, how can you differentiate a given function? How can you find the gradient function? How can you find the derived function? Or how can you find the derivative just from an equation? So, if we have the equation in this format, y is equals to x raised to power n. We want to find what we call the gradient function. We want to find the derivative function, or we want to find what we call the derivative function. So we're going to take the change of y over the change of x is equals to, we're going to take the power which is here just to be the coefficient at this point. So we're going to take n x. So we're going to subtract 1 from this power. So it's going to be just 1 minus 1. So these ones, all by doing this, we have done what we call differentiation, or we are finding what we call the gradient function. So if we have the numbers, or the numerical numbers, the function, for instance, is equals to x raised to 3. So what we're going to do, if we're going to find just the gradient function, the derived function, the derivative function, the derivative, all differentiate. So we're going to find change of y over change of x is equals to the power which is here, power 3, is going to be our coefficient here. So it's going to be just 3. X, this is 3, we're going to write 3, take away 1. So our dy over dx is going to be just 3x raised to power 2. So what we have done here, we have done, or we have differentiated, or we have calculated what we call gradient function, or derivative function, or derived function, or the derivative. Now, the questions which we have here, that is y is equals to x squared. We want to find the gradient function. So the gradient function, we say dy over dx is equals to. So we're going to take this power which is here to be coefficient here. So we are going to have 2x 2 minus 1. So we are going to have 2x raised power 1. So it's not necessary to write this, then we can have 2x as our gradient functions, or as our derived functions. I want to give another example. Which is let us have these ones as Roman 1 and these ones as Roman 2. So we want to find the gradient functions of y is equals to x raised to power 3. So what we're going to do, y is equals to x raised to power negative 3. So this power, we're going to put it here. So it's going to be dy over dx is equals to, this is negative 3, so it's going to be at this point, so minus 3x. So we're going to raise negative 3, take away 1. Negative 3 minus 1 is going to be negative 4. So our gradient function is going to be negative 3x raised to power negative 4. This is what we call the gradient function or the derivative. I want to give another example. So let us have Log 3. And the question is, y is equals to 4x squared plus 3x plus 12. So we want to find the gradient function of this. I have said the gradient function. Let us have first the function. The function is y is equals to 4x squared plus 3x plus 12. So dy over dx. So we are going to differentiate only where we have just x. So here we don't have the value of x. So we're not going to differentiate this. So we're going to differentiate now up to this point where we have x. Now we're going to have, this is the power. This power, we're going to multiply the coefficient which is here. In this case, it's 4. So we're going to take 2 times 4 is going to be 8. So it's going to be 8x. So this is 2. This is 2. Take away 1. It's going to be 1. So we're going to have just 1 here. Plus, if we don't have a power here, we assume that the power here is just 1. So we take this 1, we multiply 3. It's going to be 3x. So the power which is 1 here, take away 1. It's going to be just 1 minus 1. So 1 minus 1 is going to be 0. So we're going to have 8. We're going to have 8x plus 3x. X raised to 0 is going to be 1. So 1 times 3 is going to be 3. So our gradient function is going to be 8x plus 3. This is what we call the gradient function, or the derivative of the functions which we have here. I want to give another one. If we're going to have, for instance, Log 4, we can have our function, this is the function, is equals to a half x raised to 2 plus 4x. We want to find the gradient function of this. Just we are going to use the same method. So the function is y is equals to a half x squared plus 4x. So we're going to take the power which is here to multiply with the coefficient which is at this point. So dy over dx is equals to 2 times a half x. 2 minus 1 is going to be just 1. It's going to be 1. Plus this power which is here is 1. 1 times 4 which is here is going to be 4. X. 1 minus 1 is going to be 0. So this one is going to be, this can cancel with this. So we are going to have x plus 4. Because this one is the same as what? This one is the same as 1. 4 times 1 is going to be 4. Now what we have here is just the gradient functions, all the derived functions, all as well as the derivative. So we're going to do so many examples. I'm going to send you some questions which we are going to practice on. I wish you all the best until we meet again. Thank you so much.